All right. Again, just big picture. I want to make sure we understand we're thinking through. All we're trying to do is lay a foundation, right? So we talked about like points, lines, planes. Kind of those are our foundational definitions. Then we've been talking about like shapes. The last one was like, okay, well, points, lines, planes, and then segments and angles. How do we measure those? And now we're talking about shapes. So we went two-dimensional. Now we're going to talk about like how do we manipulate those shapes? Because they don't always. I just think to our point is like you guys saw on your graph on your homework, it was a square, right? But it was kind of slanted. So maybe it's a little bit harder to tell. And if I was like, ooh, compare this shape to another shape, you'd be like, well, they're rotated around. It looks different. So that's what we're trying to figure out, because not all of our pictures will look the same. So we talked already about congruent. They're the exact same shape, the exact same size. Now we're going to talk a little bit more about transformations. Okay, so transformations. Okay, so a transformation is a function. Does anyone remember what a function is from algebra?
It's like when you plug in y or something, you get like
Okay, sure. Typically, we like input, output, we plug in an x, we get a y. The key is, for a function, for every x that you plug in, you can only get one y. You can't get two different y's. Okay? Again, think about a keyboard on a computer. If you press the letter A, and sometimes it gave you A, and then other times it gave you like F or G, that would be really confusing. You'd be like, my keyboard doesn't work. You're like typing your papers, and like every time you click A, it's just random letters. Not helpful, okay? So you type A, and what comes out every time? A, right? That's a working function. So a transformation is a function, and it's going to take a shape, a figure, and that's what we call the pre-image. It's before we've done anything to it. So before we've done anything, the pre-image, into a new figure called the image. So it's going to take something and it's going to change it. Okay? It can change the position, where it's located, the size, and then there, like some of them, most of the ones we talk about don't necessarily change the shape of the figure. So, got this little guy here. Here would be like an example. Okay, where we took the pre-image and now this is the image. What did we do? What changed? Okay, the letters are just for us to realize that it's not the same exact shape, right? If I had two ABC and ABC, that'd be confusing because like I can't have A be in two different, like point A can't be in two different places at the same time. So we took this guy, and what did we do with it? Okay, she's using the word like we shifted it. We moved it, right? Okay, we'll talk about some of those things, okay? Think of another example. Maybe we could do something like this. Okay? And then this is like computers do this at one time. So let's say I take this, but I can do this. What did I just do? I made it bigger. Okay, it's called a dilation. You guys know how you get your pupils dilated? Okay, so you can make it bigger or you can make it smaller, okay? And I just like change the shape of it. So, or I could move it like that, or I could also do this.
Rotate.
I could rotate it. Those are all different kind of transformations, okay? We typically are going to focus on congruent transformations. This semester, we'll do one non-congruent transformation. And these ones are called isometry. That's just a fancy math word. If you see that in your textbook, that's what we're talking about. So it's a congruence transformation. Where I don't do this. If I do this, it's not congruent anymore. I just changed the size. Okay? So first semester, we're not going to change size at all. Today, we'll talk about it a little bit, but most of the time we don't. Okay? So here are the three that you guys have seen before at some point. Whether or not we remember, that's a good question. You have a reflection. Okay. A reflection is also called a flip. Okay. All right. Well, I'll draw some examples in a second. You have a translation, which is often called a slide. You slide things over, right? Or a rotation. or turn. So oftentimes you'll hear is like flip, slide, rotate. Okay, so some examples. Okay, reflection, because I think it is important we think through these really quick. Okay, normally when we do a reflection, we reflect over a line. So I'm going to reflect this guy over this line, and it would look something like this. Okay, I know it's not perfect, but you get the idea. Okay, are we okay with that? When we look in a mirror, if you raise your right hand, what is your mirror image doing? It's actually raising its left hand, right? Okay, from the mirror perspective. Okay, so it's going to kind of do almost the opposite, right? And you understand that if you've ever like held up, done a mirror message where you write backwards and you hold it up to the mirror. You guys ever done that before?
No.
Okay, right. So you write a word, all right, and then when you hold it up to mirror, it's backwards. So if you want a mirror message, you write something. It looks like nonsense, but you hold it up to a mirror, and it says. It's like The Shining, which is not a movie I'm recommending to you, but that's the whole thing. This little kid's like walking around saying red rum all the time, and everybody's like, what? And you spell it backwards, it's murder, okay? Like, that's, sorry, spoiler, okay? All right. So we have this idea of like, oh, okay, like a mirror image is when you write something backwards, and then you hold it up to a mirror. Ooh, it's actually going forward, so you can understand. Okay? If you ever look at an ambulance, the front of ambulance says ambulance. It says it backwards. Okay, that's because when you're in your car, you're supposed to be able to see in your rearview mirror that it says ambulance the correct way. Make sense of it? Okay. Right. So you're like, oh, there's an ambulance coming, and you can actually read the word.
Don't
Okay.
you just hear the siren?
That would be helpful too, but if you're
just
deaf,
look at,
you know.
But if you look at the thing,
If it's really close to you, right? Because they're like, get out of the way, and you haven't moved, and you're deaf, and you can't hear those things, you know, like, then it's helpful you could read.
well, but you can see the van.
But if it's really close, all you see is a big van.
And it's just
A big
But you wouldn't see it if it's really
van.
close.
That's true, but you wouldn't hear that. But you're so.
I'm just covering all my bases. This is why the lights, you guys, by the way, like red light, green light, yellow light, it's not just one light that just changes colors. Because some people are colorblind. Right? So it's like, hey, on the top, we know it's red. When the top light's on, that means stop. When the bottom light, if otherwise, imagine you had just one light and just change color. Then the poor colorblind people are like getting in accidents. It wouldn't be good. Okay? Right? So a translation. Right? I'm going to just use this one. A translation is when we take an object and we just move it. Okay? Those aren't perfect stars, but you get the idea, hopefully. I apologize. All right? We're just moving it. I always like to think of these like, again, a mirror image is helpful because if you think about a mirror image, it's really important. Okay? A mirror image, again, it does the opposite of what you do. I raise my right hand, my mirror image raises its left hand. Also, the distance I am away from the mirror, my mirror image is away from the mirror also. Okay? If you are 5 feet away from the mirror and your mirror image is like right up on the mirror, like run away. That's terrifying. Okay? Like you're about to get sucked in and trade places with the mirror people. Like that's the horrible thing that is. Okay? All right? Translation. Okay? Think language. Right? There's one time I was in Malaysia and I was preaching. And I had a translator. Right? And their job was to take everything I said and communicate the exact same thing. Right? So it's the idea, this shape and this shape are the same thing, it's just in a different location. Right? Different language. Okay? And then the last one is a rotation. And there's different kinds of rotations. So I'm going to like physically show you up here. Okay? You've got a rotation like this. And this is like what this board is programmed to do. It rotates this object around a center point. So it's kind of rotating around that. I didn't put that in the right spot, but you kind of get the idea, right? There's like a center location, and you're like, okay, that's where it's rotating around. I wish I could get it in the exact right spot. I don't think I can. It's a little better. Not perfect. Okay, so there's that kind of rotation, and then there's also rotation around an object that's outside of that. So maybe if I did this thing would rotate, and it would go around this. Practical, the Earth rotates around an axis. The Earth also rotates around the sun. So there's two types of rotation, right? So the Earth is going around the sun like this, but at the same time, it's spinning around its axis. So it's doing this like double rotation. Okay. So we've got kind of those different types of rotations. Okay? And what our job is this. What we're trying to do in our class is we are often comparing one shape to another. And oftentimes they're the same shape, but because they're flipped over and they're rotated around, it's hard to figure out what pieces match together. And you have to kind of, in your head, you have to be able to like, oh, okay, these two pieces match. Okay? So if I look at this one's not too bad to say, oh yeah, this belongs to this. Those are the same. Okay? But this one maybe is a little harder to recognize. Ooh, these are exactly the same shape. This one belongs to this guy here, and it's rotated this way. Okay. So by the way, sorry, I didn't say, which one is this? Okay, this is a translation. This one is I already said this one. That would lead me to believe that this one is a reflection. Okay. Later on, we are going to go back to these concepts and we'll do them more specifically. Like, hey, how many degrees did this rotate and how do we figure that out? How much did this translate? Okay. And reflection, where is the line of symmetry that it's reflecting over? Or the line of reflection. Okay. So these are some basic rules to know for some of these, like on a graph. Most of the time in this class, what we're trying to do, geometry really like is a side step, but we're trying to help you not lose all of your algebra. Okay, so we kind of put some of these things in to help us work with graphing and remember this. They want us to reflect something over the x-axis. I want to show you why this works. I want to make sure this makes sense by kind of doing some of these. So if I take p, -3, 4, 1, 2, 3, 4, this is p. If I reflect that over the x-axis, which is here, it should be straight in front of it, same location, and same distance away. So it's going to come down this way. So it would go down to here, 1, 2, 3, 4, right here. I'm going to call this p prime. Okay, p with a little like apostrophe. Okay, that's called prime. Okay. If you know anything about Transformers, like the movies Transformers, there's this guy named Optimus Prime. That actually came from here, from math. Okay, because the whole point of the show is that they transform, they change, and so you have this idea of transformations in mathematics. You say p, and then we want to know that this point and this point match together, but they can't be the same letter, because p can't be in two places at one time. Okay, right? So you got p and then p prime; those go together. Okay, so notice all that changed between those two coordinates is what? This coordinate is now 3, -3, -4. So all that changed was the y. So you can kind of see here what they're saying is if this is the original, the new one is the same thing except for we took the y value and we made it the opposite. I want to be careful. It's not always negative, because if it starts off as negative, it turns into a positive. So like what would s prime be? Ooh, that was fun. Okay, -3, +1. Right? So yeah, -3, 1, 2, 3, +1. This would be s prime, as opposed to s, which would be here. Okay. I'm just going to draw it. I'm just going to draw the new one, not the old one. Okay. What about r? Or r prime, sorry. Yeah, -6 and -2. And so you'd have a nice little triangle here. Okay. I think if I didn't put this up here, I think you guys would be able to come up with this. But I put it up here. I want to make sure we think through it. So if they ask you to reflect over the y-axis, well, now we're just flipping this way. So notice, does the height change at all? No. And height is determined by your y value, so the x value becomes the opposite. Okay? So this is just kind of like different. I want us to be familiar with the way they're writing this, just so we can think that way. That might help you long term. Okay? All right. A translation. Okay. We use this thing called vector. A vector, you guys know direction and magnitude. Oh yeah. I'm trying to think. Despicable Me, is that what it is?
Yeah.
Right. Okay. So just so clear, if you're watching that movie, when he introduces himself as vector and he says, "Because I'm committing crime with both direction," that's the definition of a vector.
Up.
So like, right, he's telling you, right? Direction tells you which way, and then magnitude is like distance. Right? So he's like, I'm committing crime with a purpose and with power. Just his idea. Right? Okay. Yes. Oh yeah. Right. Okay. So this is just telling you. Listen, what this is when you see those pointy arrows, it's a vector, and it's basically telling you how much are you moving things. I'm moving my x values by -1, and I'm moving my y values by 2. So basically, a lot of times you'll see a little vector goes -1, +2. We're going to move each point by like a little vector. That's how much we're moving each point.
Yeah.
So imagine if I graphed this guy. Let me graph it really quick. -2, 1. -1, 1, 2, 3, 4. 3, 1, 2, 3, 1. And 4, 4. Okay, what kind of shape is that? It's a parallelogram. All they're saying is I want you to take every point and move it this much. This one, this one, this one, and this one. Or take the whole shape and move it that much. Okay, now again, I have this board and I can do that really easy. But for us, without a smart board, what we're going to do is you just take every x value, take one of these. Say I said a, -2, 1. And I'm going to run it through this vector. So I'm going to subtract 1 from my x value and add 2 to my y value. So it becomes -3, 3. -1, 2, 3, 1, 2, 3. Okay. 1, 2, 3, 1, 2, 3. Does everybody see that like that's taking this thing and I'm moving this one point, if I can grab it, that much? Can I see how that works? So we're just doing that with every coordinate. Okay. So you guys help me out. What would b prime be?
-2, 6, I think.
-2, 6. Yeah. Good. You don't have to add the I think. You add it. I know.
Like being wrong. So.
Yeah. Okay. Right. So they'll always give you the instructions. They can also tell you, move it to the left 1 and up 2. That would be the other way. They'll tell you specific directions. It's like what you guys do on Google Translate, right? You're like from English to Spanish. Not that you would ever do that, or Spanish to English for your Spanish homework, yeah? Right? But like you want it to go from one language to another. You're giving specific directions. That's the same thing that's happening here. Okay? All right. For rotations, okay. These are the 3 most common, but I want you to see that this is like really easy. And I want you to see that it's really, really easy. And so I'm going to show you with a graph really quick. Okay? And grab a graph. Like if I didn't give you those instructions, I want you to see why you guys can understand this very carefully. You don't have to do this really quick, but I'm going to move that point. Okay, so this point is at 2, 3. That's where we're starting. Is everybody okay with that? Okay. I'm going to take this, and I just want you to see, because physically you could do this, even if you didn't have a smartboard, you take a piece of paper, okay? If I took this and I rotated it 90 degrees, now notice, I want to be careful. Does everybody see I did go this way? Okay, because when we measure angles, we start with 0, 90, 180, 270, back to 360. Okay, where is this point now?
-3, 2.
Okay, so for 90 degrees, we switched them, and we made this value negative. If I go 180 degrees,
-2,
-3. So I didn't flip it at all. I just made them both negative. And then 3, -2 is 270. Okay, that's what this says. But I want you to see, but here's what's nice. Listen, in the middle of a test, if you didn't know this, This is the way to kind of like, they're telling you, ooh, you flip them and you make the y negative, right? If you literally just drew this on a piece of graph paper and you turned your graph paper 90 degrees, it's vertical and you turned it horizontal, then you'd be like, where's that point now? If I turned it 180 degrees, where's that point now? So you could say like, you could teach yourself even in the middle of a test if you didn't know how to do it. Does that make sense? Okay, please don't pick a point like 3, 3, because then it's going to be hard to tell what happened, right? So 2, 3, or 1, 6, and then figure out where does everything go.
So is, are they gonna ask us like, let's say 100 degrees, or does that come later in life?
Yeah, that'll come later this year.
Oh, okay.
Yeah. So for right now, we're just introducing the idea. We're going to do like really simple ones, 90, 180, 270. Okay. But we will deal with like rotations of other measurements later. And normally we don't do those on a graph.
Yeah.
Okay. So for right now, we're just introducing, just saying like, hey, all these shapes, they can move, and this is how they move, and we want to be aware of that. Okay? So that's your homework.